All right, so now we start chapter 4. It's called integration. And integration is basically just the opposite of differentiation. A better word for it is an inverse. Just like everything else you've learned in math, all these operations you've learned have inverses, starting with addition. Way back when you learned that 5 plus 2 equals 7, and you learned that the inverse of addition was subtraction. So 7 minus 2 was 5. So addition made 5 equal to 7, and subtraction changed that 7 back to a 5. That's very basic, but same thing with multiplication. You learn that if you took 5 and multiplied it by 2, you'd get 10. The inverse of multiplication is division, which means if you took 10 and you divided that by 2, division now, you get 5. And you can go all the way up to logs and trig functions, and you learn that 2 to the third was 8. And remember, the inverse of an exponential function is the log with the same base. So log base 2 of 8 should equal 2, or I'm sorry, should equal 3, and it does. So those are all inverse functions. They undo each other. So integration is an inverse of differentiation. So we learned that the derivative of, say, x to the fifth is 5x to the fourth. So the integral or antiderivative, these are interchangeable. The antiderivative, which is the inverse of differentiation of derivatives of 5x to the fourth, must be x to the fifth. So that's the basics. We learned, if you watch that Jeopardy video before this, we learned that there's more than one answer for antiderivatives. In other words, if I said the derivative of x to the fifth minus 2, we know is 5x to the fourth, that means the antiderivative of 5x to the fourth doesn't have to be x to the fifth. It could be x to the fifth minus 2. It could be x to the fifth plus or minus anything, as long as that anything is a constant. So that's what antiderivatives are. And I'm going to kind of piece this up into a few videos. The next video that you should watch here is how we're going to represent antiderivatives. And then we're going to learn a nice formula for it.